All right, so let's take a look at a more concrete example. Let's compare two solutions to the same problem. All right, so here's our problem. Suppose we want to write a function that calculates the sum of all numbers from 1 up to and including some number n. So if we plug 3 in, we should get 1 plus 2 plus 3, which is 6. The most common, or the easiest to come up with solution, this is the one that comes to my mind first, is to basically create a total variable, an accumulator, and loop through all those numbers and add them in one at a time, starting at 1 all the way up until n. So that's what I've done here. We have a for loop, total variable starts at 0, and at the end we return total. We start the loop at 1, we go up until n, each time through, total plus equals I. Okay? And I actually have, there we go, I have it open as a snippet here. If you're not familiar with snippets, basically it's a way for me to just, rather than copy and paste code into the console and have to deal with losing it and rerunning it and that pain, in Chrome, you can go to the Sources tab, and then there's a Snippets tab you can click on, and it allows you to create new snippets. I have a couple of them here, and I'm going to use them in this course quite frequently as an easy way to save code and execute it. And just to show you how it works, here's the same add up to function, and I'm printing it out at the bottom, the result of adding up to 6. So that should be 6 plus 5 plus 4 plus 3 plus 2 plus 1. To execute it, I can either click over here, or you can see the shortcut it suggests to me on a Mac is Command Enter. It will say the correct shortcut on a PC. I think it's Control Enter. So if I do that now, I get 21. If I did it with 3, or yeah, there we go, I get 6. If I did it with 100, I get 50/50. Okay, so that's just to demonstrate that that works. Next, there's a second solution. There's more than these two, but these are two that I'm going to use because they illustrate my point. This one is definitely less intuitive. As you can see, it's a lot shorter. It's a single line, which doesn't necessarily make it better, but it's very different. There's no loop involved. What we're doing is, it's more of a mathematical formula. We take n and we multiply it by n plus 1 divided by 2. And where this is derived from, I'm not going to go into. I do have slides on it, or a slide that talks about how we arrive with this formula. If you want to check it out, you can, but it is not, it's not the focus of this video. So I don't want to distract from the actual focus, which is evaluating and comparing these pieces of code, not actually diving into how we write them. So just to show you this one, it does work. I have another snippet over here. I can run the same thing. Let's do it with 6 again. And I'll do Command Enter to execute, and I get 21. And just to walk through what happens there, it's the equivalent of taking 6 plus 1 first, which is going to give us 7. And then we multiply that by 6, which gives us 42. And then we divide by 2, which gives us 21. So it does work. It gives us the same answer in the end. Again, how it works, we'll leave that be. All right, so we established there are two working solutions. Which one is better? And of course, the first thing that we could ask is, what does better actually mean? Does it mean the faster code in seconds or milliseconds? Does it mean the code that's fastest when we're adding a small number versus a large number? Let's say we want to benchmark it at when we add up all the numbers between 0 and 1 billion. Is that a good test? Or is it about how much memory is used? Is it, the number of variables that are created, the data that is stored each time that function is called? Or what about something like readability, legibility? How important is that? Is that better? Or brevity, that's not on here, but a lot of people care about that. They like to minimize the length, the number of characters used in their programming. Not my style personally, but definitely valid. All of these are valid concerns, and it really comes down to the situation. But I think most people would agree that the first two, especially for now, we're going to focus on speed. We'll come back to memory usage in a bit, but these two often can be more important than something like readability. And unfortunately, they often come at the expense of readability, and that's sort of the balancing act of writing good code, is writing efficient code that doesn't use up a ton of memory, but also is still readable and doesn't look like complete gibberish. So we're going to talk about basically how all of these play together throughout the entire course. It will be a recurring theme. But we're going to focus on evaluating speed, how long code takes to execute. That's where we're going to start. So how do we do that? Well, the simplest way would be to use something like built-in timing functions, something like this, where we have our first add up to, And then I use a function or a method called performance.now, which in the browser is just going to tell me the number of milliseconds since the document was created, basically since I opened the window. And then so I'm going to save that to a variable before I call addUpTo. Then I'm going to call addUpTo with, what did I do? Is this a billion? I think it's a billion. So I'm going to call it with a large number. And then after that finishes, I'm going to check performance.now again, which should have incremented a bunch of milliseconds, most likely. So I have two numbers. Then I just subtract them the second time minus the first time. And I divide it by 1,000 because it's in milliseconds and I want to work in seconds. We don't have to do that last part. And I print it out. So this should work. And I actually have a snippet right here. Same thing. So addUpTo, our same one from before. And we're calling it with 1 billion. And we're going to print out how long elapsed. Let me clear my console first. And I'm going to execute it. There we go. 1.2575 so on seconds. Let me do it one more time. And what you'll actually see, I don't think I executed it, there we go, is that it varies. So it changes. Even on my own computer, nothing really has changed. Right? I haven't added code. I haven't changed the numbers here. It's the exact same code, but we're getting a different output. Before I forget, let's go over to this second solution. So the exact same number, let me just make sure I didn't leave off or add a 0. Yes, they are the same. And I'm doing the same thing, taking performance.now at the beginning and performance.now at the end. I guess I should show what that looks like. You can see that it's kind of a large number at this point because I've had this open for a number of minutes. If I refresh the page though, which I just did, now it's at 2,000 milliseconds, which is 2 seconds. And now if I did it again, we're at 6.6 seconds. And if we subtract the 2, it's 4 seconds roughly in between. Anyway, we're doing the same thing here. Okay, so now if I run this, you can see we get a way smaller number. But it's still, actually, I guess it doesn't look like it's changing here, is it? The measurements, the differences are too small really to capture. But my point is that this is significantly shorter in duration with the same data as this one. Here we go, 1.24 seconds compared to basically 0 seconds. So that seems like a good sign for this solution. It seems like it's much more efficient, and that's great. But this process, it's not the most reliable of manually timing things like this before and after and comparing it to the other function. And it's not that easy for us to talk about. How would I actually write down, how would I give it a label of how efficient this one is compared to this one? Is it based off of the percentage of speed? Is it do I subtract the number of seconds or milliseconds? It gets a little blurry. This brings us to the problem with time, which I'm reserving for my end-of-life memoir title, The Problem with Time. It's just a nice little, sounds very deep. So the first is that different machines will record different times, so it's not reliable. Depending on the specifications of a machine and what's currently happening on that machine, what code is running, the results you can get will be different. That doesn't really mean that we'll get the opposite results where the first solution is suddenly faster than the second one, but it means that the margins could change. The actual measurements could be different and are almost guaranteed to be different times. And as we saw, the same machine will record different times. So in my browser, I just did the exact same code, that first example, and it differed each time by a little bit, which isn't really a problem. But it still shows that it's not precise and that we can't rely on that. And second of all, or third of all, I guess, is that for fast algorithms, things that are happening on a really, really fast scale, speed measurements might not be precise enough. We have 2 or 3 or 4 algorithms and they're all super fast and they're doing something very quickly. There still is one that is going to be fastest or most efficient. But if our timing functions can't figure it out because they're, the smallest interval of time that can be measured isn't good enough, then it doesn't really help us. So how do we walk through our code and actually talk in general terms about which code is better without having to go and time it? So I want to be clear, I'm not saying that timing your code is a bad idea. I do it all the time. What I'm more saying is that it would be cool if there was another way that didn't involve having to set up a new file and actually go through the process of timing our code. What if our code takes, an hour, something massive, and I'm comparing it to another version that takes 4 hours. I don't want to have to run a test to figure out which one is faster. We want to be able to assign a value to, in general terms, talk about how code compares to other code without having to go through all of this. And that's where big O notation comes in. And that's coming up next. Cliffhanger, sorry.